애들은 몇 명 하지? 두 명.
Hello everyone, my name is Chen. I'm current master student of Institute of Ecology and Evolutionary Biology at National Taiwan University. Today I will be presenting a free roaming dog as a conservation challenge for native mammal species in Taiwan. Even though dogs are considered an invasive species, this topic has recently sparked intense debate here. Shows a severe conflict between free roaming animal welfare and native wildlife conservation. Owing to the urbanization, human behavior impact nature, and this includes feeding free-roaming animals, bring native wildlife into contact with human subsidized predators. Here, free-roaming refers to unrestricted movement, regardless of ownership, lack of confinement, and feeding by humans, and access to the habitat increases contact with wildlife. Free-roaming dogs populations are often demographic systems. Birth, abandonment, and immigration add individuals, while mortality, adoption, sheltering, and immigration remove them. Net population change and recruitment are therefore the key measure of management success. Opponents of dog removal often argue that if we feed stray dogs, they won't attack wildlife. However, food subsidies can relax resource limitation of dog population and maintain high dog density near wildlife habitats. At a global scale, domestic dogs are documented threats to at least 188 certain vertebrate species and have been associated with 11 recorded extinctions. These affected species occur across multiple regions. The map represents reported species counts, also sourced from the literature on the preceding page, illustrate the widespread impact across Asia. Dogs affect wildlife through predation, harassment, competition, disease transmission, and non-consumptive behavioral disturbance. In Taiwan, abandonment, unrestricted old dogs feeding create a feedback that continually replenishes free-roaming dog population and increases survival near settlements. I will examine these problems through two published protected area studies. The first case is Yangmingshan National Park, a protected area behind the Taipei metropolitan region. This setting creates strong gradients in settlement proximity and dog activity. There are people constantly feeding the animal in this area every day. As you can see in the picture, now that the issue is getting more attention, feeders no longer dare to feed them so openly, though the behavior is still spot occasionally. Returning to the focus of study. This is a study using data collected by camera traps. Professor Yan Shiqing and the team sampled 121 camera sites between 2012 and 2017. And they obtained about 6,000 detections from 9 native mammal species, together with the dogs and the cats. Dog and cat activity was quantified using the Relative Activity Index, or RAI. Independent detection per 100 trap nights. And the study includes 9 medium to large body native mammal plus invasive species, the dog and the cat. The study species, including these three, illustrate common taxa with different conservation status and ecological traits. Some of them are endemic subspecies and is near threatened in Taiwan. Let's look at the spatial pattern. As a result, the y-axis represents the estimated native mammal species richness at each camera site, and the x-axis represents distance from settlements. Estimated richness increases with distance from human settlements. Dog activity shows a stronger negative association with native mammal richness than settlement proximity. For the temporal pattern, the y-axis is the coefficient of deal activity overlap, ranging from 0 to complete temporal separation to 1 for complete overlap. The bars represent 3 seasons and different letters indicate statistically distinct distinguishable seasonal epidemic. At the community level, overlap with dogs was lowest during April to July, and 6 of 8 native species included in the temporal analysis shows seasonal variation in overlap with dogs. This period coincides with the breeding season of several native mammals. The key message is that the higher dog activity associated with lower native mammals, the richness and seasonal shifts in the activity shows how urban pressure can influence protected areas. And this is about my personal experience encountering these things happen, but due to the time we should move to another issue. Since we understand the problem, some people say that sterilization can be the solution. The work trap, neuter, return, TNR, often implemented as TNVR to include vaccination, is using to manage free-roaming dogs in Taiwan. However, because these dogs are ultimately returned to the wild, achieving actual population reduction requires extremely strict conditions such as a high sterilization rate and a closed population. Let's look at our next case study to see this in practice. There are natural parks surrounded by the 3 million population city in the southern part of Taiwan. It provides a longitudinal case in which dogs and wildlife trends were monitored across major policy and management changes. So let's look at the timeline. The local no-kill policy started in 2014, followed by national legislation in 2017. Furthermore, a high-intensity TNR program was launched in the park in 2018 because camera trip surveys were conducted across the timeline. They allow us to temporarily compare dogs and wildlife indicators before and after these interventions. In these panels, a red circle shows the relative abundance index or RAI reading against the left axis, while blue squares show estimated occupancy probability. And the right axis, dog RAI increased markedly between 2014 and 2017, and then declined moderately after the TNVR program began in 2018. However, dog occupancy remained high, indicating that dogs continue to use a large proportion of the sample landscape. In contrast, the Mahjong RAI declined by then 95% between 2018 and 2022, while estimated occupancy fell either, shows that dogs remain widespread without both camera trap activity and site occupancy of risk margin declined sharply. Mask plum civet RAI declined after 2018 as well. Why is sterilization alone insufficient? Ecologically, sterilization only limits future recruitment. It doesn't remove the existing predators already interacting with the ecosystem. Furthermore, continuous immigration offset population losses, while food subsidies maintain high survival and local site fidelity. The critical management implication here is the time lag. Native wildlife population can decline before fertility control achieves any reduction in dog abundance. Ultimately, this is a systemic problem driven by human behavior. To truly fix it, we must implement comprehensive environmental education to the public understand the ecological reality behind the feedings. We need robust policy intervention as well. This includes improving shelter capacity, which is a necessary step to facilitate the effective removal of free-roaming dogs from vulnerable habitats. We must also recognize that allowing dogs to run free is detrimental to their own welfare. In the wild, these animals face severe conditions, including poisoning, malnutrition, disease, and fatal injuries. Continuing to feed them only prolongs their suffering in an environment where they do not belong. So evidence-based management should combine source control, removal from sensitive habitats, and long-term monitoring. The scientific data demonstrate that free-roaming dogs as invasive species that threaten native wildlife. From a biodiversity conservation aspect, the protection of native species and the ecosystem integrity must always be our absolute highest priority, although the dogs and cats are cute. So this is my presentation today. Thank you very much.